Have you ever looked at a weather app that says low pressure, expect rain, and wondered, how do they know? What if I told you a simple device invented over 300 years ago can still predict the weather with remarkable accuracy? That device is the barometer, a tool that measures atmospheric pressure, which changes depending on the temperature and the moisture in the air. When air gets warmer or more humid, it becomes lighter and the pressure it exerts drops. This change in pressure is seen as a change in the barometric height or the height of the mercury column in a barometer. Meteorologists and even sailors have used this information to forecast storms, rains, and even dry spells. As you'll see in the diagram, a falling mercury column often means trouble, while a rising one brings relief. Let's now explore what these changes really tell us about the weather. Now picture this. You wake up to find the barometer has dropped sharply overnight. What does that mean? A sudden fall in barometric height means a rapid decrease in atmospheric pressure. This usually happens when a low-pressure system moves in quickly, often carrying warm, moist air. That air rises, cools, and creates strong winds and cloud formation. This pressure drop is a classic signal of an incoming cyclone or storm. Nature is trying to warn us, and if we listen to our barometer, we can prepare before the storm hits. That's why fishermen, farmers, and even airline crews rely on sudden pressure changes to adjust their plans in advance. Okay, now let's imagine a more gentle situation. Over 2 or 3 days, you notice the barometric height is slowly falling. Nothing dramatic, just a steady dip. This gradual decrease in pressure means the humidity is increasing in the air. As moist air gathers and rises, it cools and condenses, forming clouds and eventually leading to rainfall. This kind of pressure pattern is very common before a rainy day. That's why your old-school grandfather may tap the barometer and say, looks like it's going to rain tomorrow. And guess what? He's probably right because physics never lies. Let's now flip the script. What if the barometric height is going up? A gradual increase in barometric height tells us that the moisture in the air is reducing. The air is cooling and becoming denser, meaning it's holding less water vapor. This leads to dry and stable weather. But if the barometric height rises very suddenly, it may indicate that air is flowing outward from that location to nearby low-pressure zones, sweeping away clouds and humidity. This often signals the arrival of clear skies and extremely dry weather. Think of the crisp, sunny days you often get after a storm has passed. That's the barometer showing a sudden spike. Now here's an interesting case. What if your barometer shows no change for a long time? If the barometric height stays constant, it means the pressure, and therefore the weather, is stable. There's no significant change in temperature or moisture, and no big air masses moving in or out. This usually means the weather will stay just the way it is, whether it's sunny, cloudy, or anything in between. In many deserts or plateau regions, barometric readings remain unchanged for days or even weeks because the atmosphere is calm and uneventful. So let's quickly recap how this humble device, the barometer, helps us read the sky. A sudden fall in barometric height means a storm or cyclone is approaching. A gradual fall points to moisture buildup and likely rain. A gradual rise suggests dry air is settling in. A sudden rise indicates very dry weather and clearing skies. And no change in barometric height tells us that no significant weather change is expected. From forecasting rain to warning us about cyclones, the barometer is like nature's very own weatherman, simple, silent, but surprisingly accurate. I hope you now have a deeper appreciation for how pressure and weather are connected, and next time you see a mercury column rising or falling, you'll know exactly what's coming. See you in the next session with another fascinating piece of physics in everyday life.